On number one, what we need to really understand is that this f of x function is a piecewise function. It's composed of three pieces. 1, 2, 3. All right, so in other words, this is really saying like y equals -1. Let me actually write that down. Y equals -1. This is really saying y equals 2x. Let me write that down. Y equals 2x. And last but not least, this is really saying y equals 6. So let me write that down. Y equals 6. Now, I don't think you guys would have a problem if I asked you to graph these three lines. Right? That would be easy, right? The only difference between graphing three lines and graphing a piecewise function that has three pieces, the only difference is the domain value here. So it says, I want you to graph this red one, but I only want to see the values that are less than or equal to 0. I only want to see the x values that are less than or equal to 0. So let's do exactly that. Let's think about the red line, y equals -1. Where would that be at? That would be a flat line crossing the y-axis at -1. It would be a horizontal line. So what I'm going to do is just show this line right here. Even though it's not the actual graph, that's the line of the complete function y equals -1. However, you only want to show the pieces that are less than or equal to 0. So let me see if I can help you understand this with this visual. I don't want to show anything that's greater than 0. I want to show everything that's less than 0. So I'm just going to cover it up like that. So all I want to show is this piece of it over here. Does that make sense? Yeah? Not only that, I want it to be a solid dot at 0 because of the or equal to down here. So it's going to have to be a solid dot down here going this way forever. Okay, so let me actually do that here. Let me draw it. So it's going to be a solid dot at 0, we said. And it's going to the left. Put an arrow on it, and you're good with that piece. Okay? Let's move on to the next one, the one in blue. It says y equals 2x. Now, let's make it a little bit more understandable. Y equals 2x plus 0. Where does it cross the y-axis? It's already in y equals mx plus b form. Where does it cross the y-axis? At 0. And how much do you rise and how much do you run? Okay, so you could technically put a dot right here, and then up 2 over 1, up 2 over 1. What I'm going to do is I'm just going to show you visually what that line looks like. Crosses at 0, and it goes up 2 over 1, up 2 over 1. Does that make sense? Whoa. Okay. So, however, the restriction here, it says it only wants you to show the values from 0 to 3. The x values from 0 to 3. So, what I want to do to make it a little bit more understandable is put this block right here at 0 and put this block over here at 3 on the x. And this is the only piece that you want to show. You don't want to show anything on this side of it. You don't want to show anything on this side of it. This is the only piece you want to show. Maybe I should do it like that. Yeah. So what we see right here is the only piece we want to show. Now, why is that? Because you only want to see the x values from 0 to 3. From 0 to 3. Is this making sense? Yeah? Okay. So let me show only from 0 to 3, and let me actually draw it. Let me take this line out of the way. So I'm going to go, we said it crosses at 0. Not only that, this is going to be an open dot at 0 because of the less than, not less than or equal to. So it's going to be an open dot at 0. Let me draw an open dot at 0. And we said it rises 2, runs 1, rises 2, runs 1, rises 2, runs 1. And I'm going to stop right there because we know we want to show the values that are less than or equal to 3. So 1, 2, 3, that's a cutoff point right there. And this one will be a solid dot at the x value of 3 up there. So I'm going to put a solid dot up here. And I'm just going to connect the dots. And there's my piece of line from y equals 2x. Okay, now it's time for the third piece. The third piece is in black right here, y equals 6. So that's really easy. It's just a flat line, no slope, crossing the y-axis at 6. So if I go to 6, 1, 2, 3, 4, 5, 6, I would normally draw a line right through there. However, I might as well look at my restriction and notice that the restriction is x has to be greater than 3. It only wants you to show, it doesn't want to show any of these negative x values. It wants to be only the greater than 3 values. And this is 3 right here. Let me actually write that in. This right here is 3, right there. Okay? So you're only going to show greater than or equal to 3. So this is where my line would be at, but I'm only going to show from here this way and put an arrow on it. And not only that, it should be an open dot. However, the open dot doesn't make a difference because that blue dot is already closed and the closed dot lands inside the open dot. So it kind of looks like a continuous graph. Does that make sense? Did I explain that well? Are there any questions on this? This is the type of question, if not the exact question, that you're going to have on tomorrow's quiz. Shall we try another? Yeah? Okay. Let's check this one out. Again, you have oh, wait. Before we move on to number 2, I almost forgot. There's a question down here related to what we just did. It says, state the domain and range of number 1 above. Okay? So, let's talk domain. Domain are your x values. So, in terms of x, now I'm talking about the x-axis here, I'm talking about left and right. Does this whole thing, does it go to the left forever? You're supposed to say yes. Does it go to the right forever? Yes. Is there any holes that are not filled in? No. Because see, this hole right here technically is filled in with this solid dot. This hole over here was filled in with the solid dot. So it really does say that it goes forever in both directions. So x equals what? All real numbers. You could just do that little R symbol right there for all real numbers. Now, let's pretend that this dot right here, let's say it was an open dot. So you'd have an open dot here and an open dot there. Then you would say, but it can't be the x value of 0 because you have 2 open dots. But that's not the case here, so it probably won't be the case on tomorrow's test. So x equals all real numbers. Let's take a look at the range now. The range are your y values. And let's think about the y, which is really going up and down, right? So the question is, does this graph go up and down forever? No, it doesn't. It does not. So what could we say? Well, we could say that your y values will be above 0 but below 6. Does that make sense? Here's 6, there's 0 in terms of y. So your x values, your y values are all going to be in between 0 and 6. And also this extra y value down here, which would be -1. So this one's kind of complicated. This is supposed to be like a compound inequality where you say 0 to 6 with y in the middle. Okay? And what symbols are we going to use? Well, we know that up here at 6, it is included, solid dot, solid line on the 6. So it's going to be less than or equal to when it comes to comparing y and 6. And down here at the 0 on y, it's an open dot, so it's not included. So it's just going to be less than. Now we also have to throw in this extra y value down here at -1. So it would also be, you could use the word or, y could equal -1. So this would be your complete range. And you'd scratch out that y. You would say this compound inequality or y equals -1. However, I'm still not sure if I'm going to put that on the quiz tomorrow. It's a little too complicated, I would say. Okay guys, so if you understand this domain and range situation, that's great, but it really is advanced, so I'm not going to put it on the quiz tomorrow. Don't freak out. But you are going to need to be able to graph this type of three-piece function.